Welcome to episode 48 of our series. Today we're talking about a major turning point in any AI project, something I call the AI project watershed. It's that moment you move beyond just using a tool like ChatGPT and start managing a whole system. Think Dify plus vLLM plus OpenAI all working together. This shift isn't just about using more tools. It's about a fundamental change in mindset. You're no longer just a user. You're becoming a system manager. This journey is all about reconciliation, systems thinking, and balancing that tricky triangle of cost, stability, and security. Let's use a metaphor to make this clear. Imagine you're running a delivery service. When you first start, maybe you only have one truck. That single truck is like using ChatGPT. It's simple. You tell it where to go, it goes there, and the job is done. You don't have to think much about logistics. But what happens when your business grows? Suddenly, you're not managing one truck. You're managing a whole fleet. This fleet represents your complex AI, stack Dify, vLLM, and OpenAI, all running at once. Now, your job gets a lot more complicated. You can't just send trucks out randomly. You need a dispatch system to plan the most efficient routes. You need to think about which truck is best for which job. Maybe one truck is faster but more expensive to run, while another is slower but more fuel efficient. This is just like deciding whether to use a local vLLM instance or call the OpenAI API. Then there's reconciliation. At the end of the day, you have to look at your books. How much did you spend on fuel? How much did each delivery cost? You have to reconcile all these expenses to see if you're actually making a profit. In the AI world, this is exactly what you do when you track API calls, token usage, and server costs across different models and platforms. It's no longer about a single monthly subscription. It's about managing a variable, complex budget. Security is another huge piece of the puzzle. With a single truck, you just lock the doors. With a fleet, you need to manage keys, driver permissions, and access to different depots. Who is allowed to drive the refrigerated truck? Who can access the high-value cargo warehouse? Similarly, in your AI system, you need to manage API keys, user access levels, and data permissions. You can't just give everyone the master key to everything. You have to implement robust security measures to protect your system and your data from unauthorized access. And finally, there's maintenance. A single truck breaking down is a problem. But in a fleet, you need a proactive maintenance schedule to ensure everything is running smoothly. You need to monitor vehicle health, plan for downtime, and have backup trucks ready to go. This is your system stability. You need to monitor your AI models, ensure your servers are up, and have fallback mechanisms in place for when one component inevitably fails. Your goal is to keep the whole operation running, not just one part of it. Managing this fleet dispatching, reconciliation, security, and maintenance requires a completely different skill set than just driving one truck. This brings us to the core insight. You've evolved from a simple tool user into a system manager. AI applications are rarely a single, magical black box. They are complex chains of interconnected components. You might use Dify to orchestrate the workflow, call a local vLLM for quick, low-cost tasks, and then use OpenAI's powerful models for more complex reasoning. Each part plays a specific role, and they all have to work together seamlessly. Your job is no longer just about prompting an AI. It's about managing the entire process, from the initial user request to the final output. You're constantly making trade-offs. Should you prioritize speed or accuracy? Should you spend more for a more powerful model, or can you get by with a cheaper one? This is the heart of systems thinking, understanding how all the pieces fit together and how a change in one area affects the entire system. This is where reconciliation becomes a central responsibility. You're not just reconciling costs. You're reconciling performance, security risks, and user experience. It's a constant balancing act. For example, using a faster model might improve user experience but increase your costs and security exposure if it's a third-party API. Your role has naturally upgraded. You're no longer just asking the AI to write an email. You are designing, building, and maintaining the engine that powers the entire communication system. You are the system manager. And this new role is just the beginning. So far, we've been talking about building and managing the system internally, almost like in a lab. But what happens when you finally put it online for the public to use? That's where the real challenge begins, and that's what we'll dive into in our next chapter. Imagine your fleet of trucks is finally ready, and you open for business on the busiest day of the year. Suddenly, you're hit with everything at once. You get a massive surge in orders, far more than you anticipated. This is your peak load problem. Your dispatch system is overwhelmed, and trucks are getting stuck in traffic. At the same time, your ordering system glitches, and you start getting duplicate orders for the same delivery. Now you have 2 trucks heading to the same address, wasting time and fuel. And on top of all that, your data starts getting messy. The status of a delivery in one system doesn't match the status in another. You think a package has been delivered, but the customer is calling to say they never received it. This is your data consistency nightmare. Peak loads, duplicate requests, and data integrity issues. These aren't problems that happen one by one. In the real world, they all hit you simultaneously the moment you go live. How do you handle that chaos? We'll explore that next time. Thanks for watching, and don't forget to subscribe for the next episode.